Hello, this is Study Smarter with Caleb, and today we're looking at arithmetic sequences. Um, and what this video has in it is what arithmetic sequence is, the formulas we use for arithmetic sequences, and also some of the examples that you may encounter, and like in all of the arithmetic sequence questions. This video has all of them. So without further ado, let's get to action. So what is arithmetic sequence, you may ask? So arithmetic sequence is a sequence where the underlying pattern is one of a constant addition. So what this means is in order to go from one term to the next, you have to add a constant term. So in this case we add 2, also here 2. See, all of them are the same. The constant term must be the difference must be the same throughout the arithmetic sequence, or it will fail to be an arithmetic sequence. So what are some of the important formulas you should take note of in arithmetic sequence? The first one, in the famous one, is the u1 plus n minus 1d. So where un represents the general term, so it can be any number, n can be any number as long as it falls in the set, and u1 is the first term. u1 is crucial when it comes to calculating sequences. And I told you can be any number, and d is the difference. So the difference between the consecutive terms is the d. Yes, and the second formula that you need to have in mind as you're calculating arithmetic sequences is this formula right here. D, as I told you, the difference is the difference between two consecutive terms minus un. And also d also can be calculated this way, un minus 1. So let me give you an example. Let me say you have a sequence that follows like this: 1 3 5 7 9 blah blah blah. So if you want to find the difference, you can either subtract 5 from 3 from 5, that's 2, or d can also be 3 minus 1, that's 2. And take note that these two must be the same for it to be an arithmetic sequence. Yes. Without further ado, let's do examples to strengthen your knowledge. So example 1, an arithmetic sequence has a first term of 80 and an eighth term of 52. So find the common difference and an expression for the general term. When I solve maths, I like to draw a line so that I have more space. The line is not perfect, but we can work with it. So they gave us u1 is 80, right? So it's important to write what's given to you so to make the calculation easier. And u8 is 52. So what we are asked is the common difference, which is d, and the general term, which is the un. So in order to do this, the first thing we have to do is write the formula. un is equals to u1 plus n minus 1 d. So for we know the value for u8, so we can simply substitute the u8 value here. So u1 becomes 80 because it's given to us, plus n is 8 minus 1, that's 7d. So To calculate the value of d, take 52 minus 80. So 52 minus 80 gives you, on my calculator, that's minus 28. And d becomes minus 28 divided by 7, that is minus 4. So to find the general term will be un, since u1 is 80 plus n minus 1, and then d is minus 4, so becomes 80 minus 4n minus 4, so that is 76 minus 4n. It's not visible, but I guess you can see it. Yes, so that's the un. So we have solved our first problem successfully. Let's get to our second one. So show that the sequence with 3 consecutive terms is 41, 48, and 55. Remember the formula I gave you for the second one, where it says un plus 1 minus un is equals to un minus 1. So in this case, the un plus 1 becomes 55 because that's the last term, and minus un is the middle one, that's 48, and un is the same as 48 again, and 41 becomes the un minus 1. So 55 minus 48, that gives 7, and 48 minus 41, that's 7. Since these values are equal, this shows us that this sequence is an arithmetic sequence. Yes, because they have a constant number that's the same. So yeah, but this one, okay, let's see whether this one is an arithmetic sequence or not. So the way we can find out this is, okay, so let's substitute for u1, u2, and u3. So that becomes 1 square minus 2, 1 plus 5. So that gives us 1 minus 2, that is 3. 1 minus 1 plus 5, that's 4. And for u2, 1 square, that's 2 square minus 2 plus 5. That will give us leave us with 5. And for u3, 3 square minus 2 times 3 is 5. So this will leave us with 8. So if you are to do the u1 plus 1 minus un is equals to un minus un plus minus 1, you will end up with 8 minus 5 is equals to 5 minus 4. This is 3 is equals to 1, and 3 can never be equal to 1. So this is not an arithmetic sequence. Yes. So for the last example, we have an arithmetic sequence has fifth term of 18 and 11 terms of 27. So find the common difference, and the first term is the general term. So in this case, they gave us the u5 and the u11, and they want us to find the common difference and the first term in the general term. So the way we can do this is, first let's assign each values. So u8 is 18, u11 is 27. So that's the only thing we know so far, but we have the formula for the arithmetic swing, which is u1 plus n minus 1 d. So for un is u5, so we simply substitute 18, and we don't know u1 yet, so plus 4d, because if you put 5 here, 5 minus 1, that's 4d. and that's our first equation. So let's find our next equation, which is by using the u11. So the u11 becomes u1 plus 10d. So since we know the u11, which is 27, we can simply do this, u1 plus 10d. So we have sorry, I have cough, I'm sorry, two equations here. So we can use substitution method in order to find the value of u1 and d. So from the first equation, we know that u1 is 18 minus 4d. If you bring 4d to the other side, yes, so 18 minus 4d, you substitute it in the u11, so 18 minus 4d plus 10d. So this gives you 27, 18 plus 6d, because minus 4d plus 10d, that is 6d. So you bring like terms together, so that leaves you with 9 is equals to 6d. So d becomes what? 3 over 2. So our job is still not done. We have to find the u1 from this equation right here. So 18 minus 4, 3 over 2. So with 2, 1, with 2, 2. 2 times 3, that is 6. So 18 minus 6. Then u1 becomes 12. So the general term will be in this form, u1 plus n minus 1d, where u1 is 12, plus, we don't know n is constant, d is 3 over 2. So the general term will be 12 plus 3 over 2n minus 3 over 2. So to bring like terms together, 3 over 2n plus 12 minus 3 over 2 times 12, that's 24 minus 3, that is 21 over 2. See what you got? Let me know in the comment section. So this is the general term. So we are done with the examples, and now let's move on to the conclusion. So what we have seen so far is the general term of an arithmetic sequence is u1 plus u1 plus n minus 1d. So please, this formula is crucial, and you should have it in your head by now, because you're going to meet it in the exam pretty frequently. So yes, so the common difference is given by the difference between any two consecutive terms. So I showed you the two of them, and then this is the one that I showed you, n minus 1. So you can use that to calculate d. And the first time in the common difference, d determines an arithmetic sequence. So any term of the sequence is uniquely determined by u1, and the recessive definition un plus 1 is equals to un plus d. So to find the general term of any sequence, you need to know the first term and the common difference. Those two are crucial. So often two terms, not necessarily consecutive, are given in a sequence. If the equation specifies that this is an arithmetic sequence, we can plug in each given value into the equation for the general term and solve an equation system to the first term and the common difference. So this conclusion links to this slide, where I used the 5th term and the 11th term to find the first term, the common difference, and the general term. So they can ask you questions like this. So these are the questions that you meet in your exam, especially if you're doing IB, SL. This will be some of the questions you'll meet. So keep practicing, give yourself a question, and then in the end you will master it. So thank you for watching this video. Please give it a like, subscribe, turn on the notification bell, and I'll see you in the next video, which is the arithmetic series, and we're going to have a detailed conversation about it. See you. Bye.